What if I told you that the bones left over from your dinner could help solve the energy crisis? Every year the world produces millions of tons of meat, and every day the bones left over from that process are simply burned, releasing CO2 into the atmosphere. Meanwhile, farmers everywhere use synthetic fertilizers to grow food. But here is the problem. Synthetic fertilizers do not break down naturally. They sit in the soil, and when it rains, they wash it into rivers and lakes, causing eutrophication. That is, when algae takes over, oxygen disappears and fish die. Here in Kazakhstan, the Irtysh River, one of the longest rivers in Asia, has retreated up to 9 meters in some areas because of this, and we have watched it happen with our own eyes. And to produce those fertilizers in the first place, the chemical process consumes roughly 1 to 2% of all energy used on Earth every single year. So we're burning bones on one side, burning energy to make fertilizer on other, and so killing our rivers in between. Two separate problems, one solution. Hydrophos Plus combines 3 components. First, bone meal, rich in phosphorus and calcium. This is our primary raw material and it comes entirely from waste. Second, xanthan gum, which forms a hydrogel matrix around the nutrients. This matrix retains 92% of soil moisture, keeping nutrients in the root zone where plants can actually absorb them, instead of washing away into rivers. Third, citric acid, which converts phosphates into bioavailable forms so plants can take them up more efficiently. Ecobone is a social-ecological startup based in Pavlodar. We collect bone waste from meat processing facilities and transform it into Hydrophos Plus, a biodegradable hydrogel-based fertilizer. So where does energy transition come in? The energy transition is not only about solar panels and wind turbines, it is equally about eliminating hidden energy waste embedded in industries we have accepted as normal. Every kilogram of Hydrophos Plus that replaces synthetic fertilizers means less energy spent on energy-intensive chemical production. Every ton of bone waste redirected from incineration means less fuel burned, less CO2 released. Ecobone does both jobs at once, with neither. We turn a carbon cost into a benefit. What makes Ecobone genuinely original is not just the formula. To our knowledge, no commercially available product globally combines bone-derived phosphates, xanthan gum, and citric acid. But beyond the chemistry, Ecobone introduces an eco-collector network, a community infrastructure for collecting bone waste from households. Bone waste is generated in every home, every day. By giving residents a simple way to sort and deposit them, we turn a universal habit, eating meat, into a universal contribution to circular economy. Let's move to the business model, and our raw material bone waste is free. To produce 1 ton of Hydrophos Plus, we need only $31, and if we sell it for $615 per 1 ton, margin makes the business resilient. We break even at just 32 tons, realistic within the first year of operation. And one more thing, this project started in a school in 8th grade in Pavlodar, not in a capital city, not in a university lab, and real innovation does not require perfect conditions. And Kazakhstan is just the starting point. Water scarcity and soil degradation are challenges shared by agricultural regions across Central Asia, Africa, the Middle East, South Asia, and Latin America, anywhere with meat processing waste, degraded soil, and depends on synthetic fertilizers. A survey of over 150 residents in Pavlodar found that more than 80% notice the negative environmental impact of conventional fertilizers. My name is Isbaeva Zarina, and despite my young age, I want to contribute to energy transition. So I want to leave you with one question. How much of what we call waste is actually a resource we just haven't learned to use yet?